that's definitely not going to work unless I tape that. And we're back. We're back live for so far the one person in the chat, which I think is just me over there on a phone. But we'll see what happens. 7:21. These people should be getting into it. But yes, here we are once again. Couple of reminders, just for those in the chat and those here live. Grades are to be submitted by teachers tomorrow. My hope is to get everything done before the end of today. So I should be able to catch up and finalize grades by like 2 or 3 o'clock today. But then, of course, any fine-tuning, last-minute adjustments. I'm not sure exactly when they're going to close grading on Genesis. It just says April 15th. Usually they close it anywhere between 7 a.m. and 2 p.m. Usually they're just like 2 p.m., 8 a.m. They usually send out emails saying, oh, we're going to extend it a day. But I doubt they'll do it this time around. We'll see what happens. Just a reminder as well, next week, y'all know you have Monday off, right? Okay, just making sure. So the way that the schedule is going to work, today is Wednesday. I have you Wednesday, Friday. Next week, I have you Wednesday, Friday as well, just so we're all on the same page with that. Because even though you have Monday off, they're going to continue lettering more A-Day, B-Day, or something like that. I know. But we'll see how that goes. And yes, as always, for those of you that have done it so far, I'm going to need a comment in the chat just so I can update that attendance. That'd be fantastic. And I'll take care of that when the time is appropriate. I'm trying to think if there's anything else that's major. There we go. Cool. Yeah. So what I would start with is this. On the Google Classroom stream, for those of you that are on the live stream, in the Google Classroom stream, I'm going to copy the link to the post. There it is. And paste. In the chat right now is a link to the worksheet that we were working on last class. I would like to work on that for this particular class period. So for those of you that are right here with me, if you guys can dig out this worksheet from last time, it said lesson 6.5 brute force algorithm. If you don't have a copy, I do have a copy just in case. You got it? All right, you got it? You got it? All right, I got extras. Yeah. Making sure. There we go. But I'm going to be working off of this particular worksheet, more specifically on exercise 3, because I wanted to wrap that one up with a slightly different method. So if you do not already have them out, I'm going to need those notebooks out and open. Now, this worksheet with this problem is asking for brute force. And I don't really want to do brute force for this one, simply because, yes, they do list out all of the possible routes for you, which is fantastic. But brute force is kind of tedious because you literally brute force the problem. You have to list out every possible route and then figure out the distance or the value or weight of that route, and then figure out which one is the best one, and then you'll get the optimal route. But there are other ways of doing things. Question, do you say route or do you say route? Isn't that weird? All right. I don't know. Just one of those things. So, in my notes, today is the 14th. I'm going to be calling this Hamilton Methods, because I'm going to be showing you additional methods besides, I can't see it. There it is. I'm going to be showing you additional methods beyond the brute force method. Brute force is nice to an extent, only to an extent. There are other ways of going about it. So, let's see. There we go. Cool. So I showed you strat 1, which was called brute force. Now, what I'm going to do is I'm going to copy this particular image into my notes, and I'm going to make all the connections. There we go. And again, it's on that worksheet, so you could see where all the connections are being made. There's a connection between every single vertice, and I'm going to write in the numbers as well. Let's see what we got here. Yeah. Oh, I forgot one. There we go. There it is. And let's see. 40, 15, 14, 13, 22. Now, the middle is going to be a little weird because obviously these lines are somewhat close to each other. So I would suggest getting a little creative with how you put those numbers on the actual image, just so you know which line represents which length. I'm trying to angle the numbers in such a way where it's very obvious which one represents which length. And of course, like I said, if you need a clearer copy of it, obviously, seeing the board is one thing and watching from a computer screen is another. I did post that link to the PDF in the Google Classroom stream. Now, in terms of brute force, if you didn't know which routes repeated each other, which routes were mirror images of each other, and you were just flat out trying to list out every single conceivable route on this image here, you would have hundreds upon hundreds upon hundreds of options that you would have to go through. Brute force does have some shortcuts in kind of a way where on this worksheet, and I'm going to bring this worksheet back up and zoom in on it. On this worksheet, they do list out the possible routes for the delivery truck starting at E, and they show the mirror image so they don't have to repeat all of them, but that's still 12 different things that you would potentially have to go through. Yes, brute force will get you your answer. However, at what cost to you and your sanity? Because I only have 5 vertices here. If I had 6 and 7 and 8 different vertices, there would be a bit of an issue listing out all of the routes for brute force. Do you guys know anybody in your lives that is a truck driver? Oh, he did? Nice. My father-in-law's a truck driver. Yeah. It's insane. Like the distances that he has to go, but he has the computer to kind of figure that junk out for him. It's just like, it's in a simple way. It's just, okay, I need a job. Type in what jobs are available. Okay, this job's available. I grab that one. I figure out my route, and then I go there. And then they have all their rules, right? How long ago was he a truck driver? 35 years ago. Oh, wow. Cool. Do you know what company? No. Okay. All right. My father-in-law, he drove for a company. You've probably seen them on the road, Swift. Yeah, he drove for Swift and he drove for Walmart as well. But I digress. Now, what's really interesting about some truck drivers' jobs, and this was my father-in-law, he would drive during the week and then he would come home on the weekends. He had the kind of job where he was able to drive Monday through Friday, and then he was able to take the weekend home. Okay, cool. But he would have to pre-plan ahead what routes he would be taking so that he would easily be able to get back home, because obviously he's not going to drive his truck right up to the house in Barnegat. He's not going to do that. Oh, they live in Barnegat, just so you know. I don't know. Anyway, shut up. He's not going to do that, but he has to figure out how to get as close as possible so someone can pick him up and bring him home so he could spend some time with his family. But again, brute force, not necessarily the nicest way. So there are other methods. One of the, I don't want to say simplest. I don't want to say simplest in terms of it being easy. I'm going to say simplest in terms of it being, just being like, oh, that's all kind of situation. Where's my red marker? I want my red marker. Yes, I threw you over here. According to this example, they want to start at vertex E. They want to start there. Now, vertex E is connected to all this other stuff. Here's the next method. I'm going to write down the rules for this next method in a few minutes. But here's the next method. If you have just started E, what is the shortest route out of E? Out of E, you could either go to A, you could go to B, you could go to C, or you could go to D. Which one is the shortest route? Say again? D? That's 22, though. Yeah, that one's shorter. Yeah. Again, I think they measured these in, I can't remember what they measured these in. For location, travel times. So they call these travel times. Again, it could be anything. It doesn't have to be travel times. But for example, it would take that much time to get to B, 13 units. It would take 22 units to get to D. So this is the route that we would have to take. Now remember, Hamilton, you have to hit every vertex exactly once. And we want to make a Hamilton circuit, meaning we have to end up back where we started, which is why I wrote the word start next to the letter E. Now I'm at B. I can't go back the way I came. I cannot go back the way I came. So I have options to go to A, C, or D. Which one is shortest? There are people in my hallway. Anyway, where can I go? I can go up to A. Say again? Yeah, D. Up. Who's at my door? Oh, hold on. Ah, goodness. Hello.
I need Allison McMahon.
She dropped this class.
Oh, great.
Sorry. Oh, surprise. She dropped this class. Surprise. She hasn't been here in like 2 months. I don't know. Anyway, but yeah, you're right. You got to go to D. Yay, boom. Now you're at D. What are my options? Well, I can only go to A or C. Yeah, it's got to be A in this case. Absolutely. It's got to be A in this case. Now, from A, you can see all the different directions you might want to go. It's like, well, I can go to B. Nope, I've already been to B. You can go to C. I've already been to C. You got to go back to E. You have no other choice. You have no other choice. You have to go back to E. But Mr. Markey, going to B is shorter. Yes, but you can't go back to B. You have to go back where you started. You're hitting every vertex exactly once. This is a method known as nearest neighbor. Nearest neighbor. Basically, wherever you start from, which in this case is E, you take the shortest route possible. Okay, well, 13 was that shortest route. Now, I can't go back to 13, but I can go down 11 to D. Now, from D, I have several options, but nope, I have to go up to A. And then from A, no other choice. I have to go back where I started. You hit every vertex. Oh, wait, did I not hit every vertex? Oh, snap. What mistake did I make? Let's get rid of that right there. Let's get rid of that right there. Say again? I didn't do C. Like a chump. I did not do C. You have to hit every vertex exactly once. Hamilton circuits, you hit every vertex exactly once, and you end up back where you started. So now I have no other choice. I have to go down to C. And then from there, I'm going to back up and go to E. Now I've hit every vertex. Ha, 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 ha. All right. Now, we can figure out the distance of that in a moment. We can figure out the distance. But I want to go back to our notes. And I want to write down this actual strategy. And I want to figure out the actual distance. It's going to be nice. Now, nearest neighbor does not necessarily give you the best option. Nearest neighbor just gives you a good option, but you're able to get it in a short amount of time. There's always pros and cons to these methods. Pros and cons. So this is strat 2, known as nearest neighbor. This is strat 2, known as nearest neighbor. There are technically 4 strategies that I am going to show you over the course of time. Strategy 1 was brute force. Nearest neighbor is this. From starting vertex, go to cheapest option each time without repeating vertices. I'll repeat that. From the starting vertex, you basically go to the cheapest option each time without repeating vertices. Remember, you have to hit every vertex exactly once, and you have to end up back where you started. Generally, my father-in-law tried to follow this strategy when taking local trucking jobs. He was mainly confined to the Northeast for a while when he came home on weekends. He went all over the country when he was traveling. He was traveling all over the country when he came home once a month. But if he was coming home once a week, he stayed in the Northeast. And the general idea is that, well, the shorter the job, I get the job done, I get paid for that one job. He tried to get as many jobs as possible done. If you know anything about truck drivers, though, they tend to get more money the farther the distance that they travel. So it's a balancing act. He wanted to stay in the Northeast. He didn't really want to travel that far. So that's what he did. Nearest neighbor. From the starting vertex, you go to the cheapest option, the shortest option, each time without repeating the vertices. So now for this example, we started at E. I believe we went to B. Then we went to D. Then we went to A. Then we had no other choice. We had to go to C. And then we went back to E. That is where we did nearest neighbor. Let me figure this out. So it was a weight of 13, a weight of 11, a weight of 12, a weight of 30, which we couldn't avoid that 30. We could not avoid that 30. And then a weight of 23. So those were the weights and time that we had to travel in order to get this thing done. 13, 11, 12, 30, 23, 89. 89 was the distance that we got with nearest neighbor. Now, is that the actual shortest distance? Is that the actual optimal route? We don't know. That's the unfortunateness of nearest neighbor. Pro and con. Pro for nearest neighbor, you can get your answer very quickly. Very quickly, you can get your answer. Nearest neighbor, you just, where's your starting point? You figure out the cheapest route in each direction, and then you go from there. Con, you may not have the optimal route, but that is okay if that is your strategy. Brute force will get you your optimal route. However, brute force does take a lot of time. It takes a lot of time. Let me show you the third strategy. Third strategy, I always pair with the second strategy, mainly because of how related they are. Strategy 3 and you'll see why in a minute. I put start. Why did I put the word start? Turn that over. Or throw it out. Paper. I got plenty of you. I just planted a tree. I lied. I didn't. Strat 3 is known as repetitive nearest neighbor. Repetitive nearest neighbor is quite straightforward, but you repeat strat 2 starting from each vertex. Basically, we're going to do nearest neighbor again and again and again and again and again and again. We're going to do nearest neighbor a grand total of 5 times. Just 5. Repetitive nearest neighbor still does not give you, or is not as not eloquent, I shouldn't say, as complete as brute force. But repetitive nearest neighbor does help you out a bit. And I'll show you what I mean in a moment. Now, just for the sake of argument, I'm going to take this Hamilton circuit up here. Here we go. I'm going to clip it up here. And I'm going to need to write the 5 routes for repetitive nearest neighbor. Now, I already have one of them. I have the one starting from E. It was E, B, D, A, C, E. And this equaled 89. We got that. That one was there. Cool. Actually, no, I could probably do better with this thing. Yeah, I'm going to bring it back. I changed my mind. I'm going to bring this back so we can see it a little bit better. So that's starting from E. Let's start from A. You tell me. If I start at A, where is the shortest route? Where is the nearest neighbor? If I start from A, I'll put the word start up here. Where am I going? Say again? Not B. D. D is 12. I'm going to go down here. Where would I go next? Then I would go to B. There's 11. Where would I go next? Yeah, it's very close. But I'm going to go this way. Yep. Oh, crap. I don't have a choice, right? I don't have a choice. I have to go to C. And then I have to go back to A. Yeah. It's the same exact route, isn't it? Sometimes that happens. We're going to see if it actually does work in a moment. So let me write something down. I'm going to flip my thing over. Let's see here. I'm going to write down. I started at A. Tell me, where did we go from A first? We went down to D? Okay. We went A, D, and then B, and then we do ECA. It also equals 89. Let me show you these letters real quick. Look at those letters right there. Look at those 6 letters right there. This is the crazy thing about routing these problems. In the first one, we had to start from E, and we went straight through E, B, D, A, and then et cetera. B, D, A. We went E, B, D, A. I'm repeating those letters for a reason. But here we went, it's a completely different route. No, technically it's the same route. Because look at this. E, B, D, A. And then it wraps around. It's technically the same route, just in a different starting location, going in a different direction. Love it so much. Do you guys know when the first smartphone was invented? Or I'm sorry, let me rephrase. Do you know when the first smartphone was put out on the commercial market? 2007. Okay, 2007. A buddy of mine, not Derek, a buddy of mine, he and I went to Niagara Falls. We went to Canada in 2005. Neither of us had smartphones, but you could still look up stuff online for like mapping things. So we were trying to figure out, okay, we were going to take a trip up to Niagara Falls. We were going to drive there, and I had to route this thing out. And the interesting thing was, back in the day, 2005, again, this is before smartphones. Smartphones do everything for you nowadays. But back in 2005, I had to manually check each and every single step of this thing and write it down off of the computer. I mean, yes, I could have printed it out, but I needed something a bit more concise. But then I found out on the way home, we actually went a different route, and it was somewhat faster. It's very weird to me to think about that nowadays, because I don't think about it nowadays. Nowadays, you literally just type in a destination into Google Maps. I'm assuming you all use Google Maps instead of everything else. Is that the best one? There are other mapping apps, aren't there? Whatever. But it gives you the optimal route. You know what I love to do? I love to go into Google Maps and I do the optimal route, but then I'll type in like avoid tolls because I don't want to pay tolls. And it adds on like 10 minutes to your drive. And I'm like, all right. I'm avoiding tolls, though. Ha, 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 ha. Let's do it again. Let's start from B. We're going to do it again, but we're going to start from B. Repetitive nearest neighbor. Start. Let's see. Where do I go first? Okay. D. A. Yeah, I have to, right? Yeah, this sucks because like I can't do. Wait, can I do 40? No, I don't want to do 40. I can't do 15 because I would end up back where I started. I have to do this 30. Oh, it's gonna be the same thing again? Oh no, I already, yeah, it's gonna be the same thing again, and that's okay. Let's just see what happens. I want to see if it gives us a different route because sometimes it will. Sometimes. Not all the time, but sometimes. But I'm going through it. So let's see here. I started at B. And then from B, we had to go to D. Yep, and then the rest of the route kind of follows suit. Yeah, watch this. Went from B to D, and then I'm pretty sure it's going to go A, C, E, B. You can figure out the routing of that situation just based on the direction of the letters. Oh, I so desperately want one of these routes to actually be different and shorter. I really hope that it's going to work out in my favor. It will. What? Yes, it will. Yes, it will. You just read my mind. Literally just read my mind. We will get a different route with C. So let me go back up. We're going to start with C, and this is where things are going to get a little interesting. Now, will it be better? Will it be worse? I don't know, but let's just see what happens. But you're right. From C, we have to go that way. We have to go that way. Where do we go next? Yeah. Then we go to B. Can't go back to C. Yep, we go across to E. Do I have to go A? Oh, that sucks. I'm going to do the 40. Well, we have to. We have to do that 40. And then we go back down to C, yeah. That's the route this time. Different route. Okay, so we get to add something else up here. We get to add something else up here for this. Okay, I'll put these letters up here. It's going to be C, D. And then where do we go? Oh, that's right. And then we went to B, and then E, and then A back to C. What? Oh, that sucks. But that's what it is. It's 107? Nice. Hey, sometimes that happens. This is a consequence of nearest neighbor. Now, we have one more to do. We have one more to do, obviously, but I just want to point something out. I want to point something out here. Boom. If we lived in C, and just did nearest neighbor from C, we would get 107, and that sucks. Repetitive nearest neighbor does allow us to use one of these routes to start from C, and I'm going to show you how we do that after we finish this last one. I'm going to show you how we can convert one of these routes to have C as a starting point and ending point, so that C can also have a route of 89. Because that's like, what is that, 18 minutes? Yeah. 18 minutes. I want to save 18 minutes. We got one more. We got to start with D. We got to start with D down here in the bottom left. Let's see. I have to go B, don't I? B, E. Oh, I have to? Oh, man. We're going to get the same thing. And then I have to go A. And then I have to go back down to D. It's the same thing. Yeah, it's the same thing. So this one was starting from D. Ow, goodness gracious. Ooh. I almost fell. Wow. That would have sucked. There we go. Do you guys know how foul language is a part of your lives now? Right? You notice that I never curse? Right? I'm just saying. One time I was helping my dad move a couch. He tripped and the couch literally fell on top of his shin. He cursed up a storm. I had never heard my dad curse until that moment. Never did. And he just let out all these F-bombs. I don't curse. I don't know why. I just don't. But even in that moment, you probably just saw that. Oh, yeah. You know those guys that like usually curse up a storm during like video games, live streams or whatever, right? Like I don't do that. I live stream video games, but usually the worst thing I'll say is goodness gracious. So there. Let's see here. We had to start at D. And then we had no other choice. We had to go to B. And then I'm pretty sure I know where the rest of this is going to go. E, C, A, D, and we got 89. Repetitive nearest neighbor basically says that you have to use every single vertex as a starting point and perform nearest neighbor in order to get a route. So now here comes my big question. We got all of these routes of 89 except for C. Come on, page. Why can't I separate you? There we go. Here comes the question now. How can we get a route of 89 starting at C? How can we get a route of 89 starting at C? C was the only one that did not produce a route of 89 using nearest neighbor. We followed all the rules. We did everything that was expected of us. But it just so happened to, it sucks if you live at C. Well, no. We can still do this. We can still potentially get a better route for C. We just have to convert one of these other routes. And that's exactly what we're going to do. We will convert E, B, D, A, C, E. We're going to convert that one. That's the first one that we found. That one has a distance or a time of 89, whatever it's measured in. How one does that is like this. It doesn't really matter what direction you start in, but you could do something like this. There's our starting point. Start at C. Pick a direction. When I say pick a direction, left or right? Sure, doesn't matter. Doesn't matter. Because what I'm going to do is I'm going to start at C, and he said left, so I'm going to go left. A, D, B, E, and then from E, it is also going to end back at C. That route will give you 89. And I'm going to go back. I'm going to go back to the map in a moment. I'm going to go back to the graph in a moment just to kind of prove that. But you can convert one of these other routes by simply starting at the point that you need to start at. Oh, using the pattern and the other routes we can. Yeah, sorry, Sydney. I literally just read what you typed. I'm going to read to you what she typed. She said, using the pattern in the other routes of 89, we can manipulate the order to become a route of 89 starting at C. Yes, 100% yes. Now, the way that I did it is not the only way. In fact, I'm pretty sure, Sydney, the route that I the route that I wrote out is the exact mirror image of the one that you typed into the chat. Yeah, it is. That's awesome. Let me go back to this route real quick, just to kind of show it. Mine spells out Cadbeck. Let's see here. I'm pretty sure Cadbeck is going to work. I mean, hers would too. But you could go C, A, there's your 30. D, there's your 12. B, there's your 11. E, there's the 13. Back to C, there's a 23. 6, 7, 8, 9. 3, 4, 5, 6, 7, 8. 89. It works for C. Love these things. They're phenomenal. Okay. Now there is one more strategy that we are eventually going to get into, but I'm going to save that. I'm going to save that strategy. I'm going to save that strategy for another day. So there is going to be a fourth strat, but I'm going to save it. Just for the sake of argument. Nicole, that's what we did, right? So the question was, how can we get a route of 89 starting at C? Because we got 107. We got 107 starting at C. And it's like, how come C can't have a route of 89 as well? Well, it can. If you pick one of the routes of 89, start at C. It does not matter what direction you go, actually. You could go to the left or you can go to the right. Patrick said go to the left, so I went to the left. And I went C, A, D, B, E, and then I had to end back up at C. You could go the other direction, and that's actually what Sydney did in the chat. Sydney went C, E, B, D, A, C, and she got the exact same route. So it is entirely possible to not reroute it, but re-express any of the routes to start anywhere you want. It's so wonderful. Okay. I'm going to go back to this worksheet one more time. This worksheet that I posted the PDF into the chat, and I obviously gave you guys last class period. I want to go back to that worksheet specifically for exercise 4. Make sure this is lined up. I'll move this up a bit. There we go. Cool. So exercise 4. Now, this is a common chart that you may end up seeing over the course of this chapter. This is a mileage chart. But this mileage chart is just for 4 cities. Other mileage charts that I'm going to have for you later on, it's going to be obviously a bit more. The reason why there are asterisks down the diagonal is because, well, the distance between Louisville and Louisville, well, it's 0. So you don't really have to figure out a distance between Louisville and Louisville or Nashville and Nashville. But you could say that the distance between Louisville and Nashville is 168 miles. You could say the distance between Louisville and Pittsburgh is 388 miles. What do you notice about the chart with that line that I drew? What do you notice about the chart? This chart can be very helpful, but it's just something I want you to recognize right there. What is it? What are they? Right triangles. They're mirror images. They're mirrors of each other. That's all that they really are. They're mirror images of each other. Look, Nashville. There's the Pittsburgh one. It's the 588. It's the 299. It's the 388. And then there's the 263. They're mirror images of each other. They're just flipped. They're reflections. That's all that they are. Just something to keep in mind when you're filling this out for a future problem or a future project. Because the project that I do have in mind for you, just so you know, the project that I do have in mind for you eventually is that you would create a travel itinerary for the United States. And you would have a certain number of cities that you would have to visit. But what order do you visit those cities in? I'm not going to have you do brute force. Oh, heck no. I'm not going to have you do brute force. But I will have you do the other strategies for completing your route around the country. Not these cities. I have other cities in mind. Just something to keep in mind. Now, obviously, if we're living in Barnegat, we're not going to start in one of these cities. But just for the sake of argument, let's just say that we lived in Pittsburgh. Let's say we live in Pittsburgh. That's where we're going to start. I don't know why I didn't just write the word start. Start in Pittsburgh. That's the closest to us right now. I know it's like an 8 or 9 hour drive or something like that. But if we live in Pittsburgh, what is the closest of those cities to us? If we live in Pittsburgh, what is the closest of those cities to us? Ooh. Nashville's 553 miles away. It's not Nashville, though. It's Louisville. Yeah, you got to go to Louisville first. So I'm going to go to Pittsburgh to Louisville. I'm going to go Pittsburgh to Louisville, and that's going to be 388 miles. This one I am going to select. Now, technically, I could also circle this one up here, but that one doesn't really matter at the moment. Now, from Louisville, I've already done Pittsburgh. From Louisville, where am I going to go next? Now I'm going to go to Nashville. Nashville is 168 miles away. Now, can't go back to Louisville. Now, technically, according to this, I do have to hit all the cities. From Nashville, I can't go backwards to Louisville, and I can't go to Pittsburgh until my last shot. I only have one option here, which is St. Louis, which is 299 miles. And then from St. Louis, I have to go back to Pittsburgh, which is 588 miles. I just performed one very basic nearest neighbor. This is one very basic nearest neighbor to kind of get this thing done, where you can map out where you're going. You can kind of eliminate choices along the way if need be. There are ways of kind of organizing this into one of those right triangles. I know you mentioned like a right triangle. There is a way of organizing this into a good right triangle. I'm going to show you how to do that in a little bit. In fact, we'll do it from another starting location. Pick a city that's not Pittsburgh, that's up here. Sure, let's start in St. Louis. But by the way, from Pittsburgh to Pittsburgh, I would add all those up and I would get a distance. The point of this is me showing you how to use this table. The point of this is me showing you how to use this table. So you want to start in St. Louis. Now, check this out. I'm going to ignore the top half real quick. I'm just going to ignore the top half of this board. And I'm going to start in St. Louis. From St. Louis, where am I going? From St. Louis, where am I going? Louisville. Yeah, I'm going to go to Louisville. Louisville. So I'm going to put Louisville. I'll just put Louisville there. Cool. So this is the distance I'm going. Now check this out. I'm just going to ignore the top half of this board real quick. I'm going to ignore the top half of this board real quick, and I'm going to go to this Louisville right here. Now, I've already gone the 263 miles to get to Louisville. I'm going to look at this Louisville up here, just switching real quick, and I'm going to go down this column. What's my shortest distance? And it's got to be Nashville in this case. Now, again, I'm trying to show you how to use this board, how to use this chart. I'm ignoring the top half of this chart. I'm just looking at the bottom left triangle right here, and I'm going to go to Nashville real quick. Now, Nashville, I'm going to select this 168 right here. Now, Louisville is done. Louisville is cut off. Louisville has been taken care of. So I'm going to cross out this 388 right here. From Nashville, I'm looking at these two numbers right here. Where am I going? Where do I have to go? Yeah, I can't. Yeah, I have to go to Pittsburgh. I can't go back to St. Louis. So unfortunately, I got to fill this thing out. I'm going to show you how to visualize this on the thing. It's going to be amazing. Anyway, now from here, Pittsburgh, I have to go to St. Louis. If you did it correctly, the only number left standing should be the Pittsburgh to St. Louis number. Again, I'm trying to show you how to use the chart. Using the chart, you could ignore one half of it, and you can mainly focus on, well, in this case, the bottom left if you want to. It could be the top right. You get the same result. But if we're going to start in St. Louis, notice that every single number on this thing was either crossed out or squared off. If they're squared off, then those are the distances that we would actually be traveling. 263, Louisville to Nashville was 168. Nashville to Pittsburgh was 553. And Pittsburgh to St. Louis was 588. And those are the distances that we would add up in order to figure out the route. It's quite wonderful. This chart. Like I said, this chart will come in handy. When you eventually get to the project that I'm going to be assigning for you, I'm going to have stuff organized into a spreadsheet. I'm going to have stuff organized into a spreadsheet where you're going to have a copy of that spreadsheet and you're going to be able to add some cities of your own. In fact, there are some cities that I have pre-selected for you and some cities that obviously you will have to select on your own. Just the way that kind of goes. Yeah. Now, I ask this with a bit of caution. Are you guys I'm going to be very specific. Are you guys very familiar with Google Maps? Like the ins and outs of Google Maps, how to like adjust options in Google Maps? No? Nicole, anything like that? Google Maps? No? Okay. I'm a bit more savvy with Google Maps, mainly because I have traveled certain distances that I've had to drive. Obviously, I mentioned driving to Canada. I've driven 14 hours to Indiana once. That was not fun. Never driven to Florida, but I've driven to a bunch of different places where, yes, I've had to use Google Maps. I was actually having this conversation with one of my Algebra 2 classes where I have actually traveled to a ton of different places, mainly for Rubik's Cube competitions. It's pretty crazy. I don't know, but I've been all sorts of places as a result. Drove to Boston. Boston was such a great drive. I want to show you Google Maps. Now, on Google Maps, now keep in mind, you are going to have to do something like this for your project. You are eventually going to have to do something like this for the project. I have not assigned it yet, but I just want to make sure that you are aware as to how to use Google Maps. Now, searching Google Maps, you can search for any destination you want. I'm going to pick Pittsburgh for the fun of it. Pittsburgh, PA, there it is right there. Cool. Next, I am going to select directions. Doesn't matter where in Pittsburgh you're going, it matters on where you're starting. In the top left, you can see that they have the words choose starting point or click on the map. I'm just going to select Barnegat. Barnegat, New Jersey. Doesn't matter where in Barnegat, I'm going to pick Barnegat. Boom. Now, notice for a second, I don't know if you're able to see this. It might be a little bit difficult for you to see, especially if you're online. But can anyone see what it's set to on the top left side? Yeah, it's set to walking. Holy crap. No, you're going to be driving. So make sure that you select the correct thing right here. Driving. Boom. Now, I would take the distance. Don't necessarily take the time, because the time can change depending on traffic, depending on construction, depending on whatever. And the shortest distance driving that I can go is 363 miles. 363 miles. It's just the way it is. Sometimes I like to do a thing where it's like you can change it, where you can avoid tolls. And if you avoid tolls, look how many hours it actually kicks on there. It kicks on like an additional couple of hours. It's really insane. But I digress. I'm going to get rid of that one. Boom. Close that up. Boom. There we go. So if I'm doing the project, I would show a distance between Barnegat and Pittsburgh of 363 miles. Then, filling out the rest of that chart, just like you have on that worksheet, I would figure out the distance between, let's say, Barnegat and the next city. I don't know, Louisville. Louisville, Kentucky. Chapow. And now, again, I'm trying to take not the least amount of time, but the least number of driving miles. And if you notice, they give you 3 options up here. Again, I'm trying to show you how to use Google Maps. They give you 3 options up here for driving. I would take the shortest distance, which in this case is 733 miles. Now, when you do your projects, like I said, you're going to have an opportunity to pick cities. But the cities that you pick are going to have to be different from everyone else's. I'm going to have some kind of organizational tool for you guys to select cities, but the cities that you pick, again, cannot be the same as anyone else's. So on the list, on the organizational tool that I'm going to have for your project, you're going to be able to look at it and be like, okay, these cities have already been taken. I have to pick 3 other cities or some junk like that. Hold on. This used to do this. I want to see if it does it again. Nope, doesn't do it. Years ago, you could type in USA to Japan, and it would give you a route. where it would take you from the middle of the United States all the way to the West Coast, and then it would tell you to get in a kayak. And actually, yeah, it did. It used to, not anymore. And it would tell you to get in a kayak and actually go across the ocean. That's pretty funny. But I digress. Let's go back here. Let's see. We'll go back to Barnegat. Let's go back to Barnegat real quick. Come on, Japan, go away. Let's go to Barnegat. Come on. Nope, that is the Kerosene. All right, cool. Let's go to Barnegat. Where's Barnegat? One of my favorite things to do is the satellite view, because you could do the satellite view and you could zoom in directly where you need to. Like, oh, just missed it. There it is. There's the high school. Can I get on the ground here? Will it let me? Yes, it'll let me get on the ground. Look at that. Where am I? There's the high school. Let me go any farther. Oh, Google cars aren't allowed on here. They haven't gone down that way. The Google car won't let me get into the high school. You ever seen the Google car? Yeah, it's awesome. It's literally, I'll show you a picture. The Google Map car image. Can I bring that up larger? No. Open up in a new tab. There we go. There it is. Look at that thing. It's got a giant 360-degree camera on top. And it literally, that's all it does. It drives around and takes 3D pictures and updates them all up to the website. Of course, people have to look at the photos first to make sure there's nothing inappropriate. But it's kind of fun. Anyway, on Friday, we're going to get a little more practice with these strategies. I'm going to introduce to you the fourth strategy. And depending on how far we kind of get, I may or may not introduce the project to you because I would like to get some extra practice with these methods before I actually introduce the project. I think my goal is to aim to give you the project next week, probably Wednesday of next week when I have you next week. But we'll figure that out when we get there. In the meantime, we have about 45 seconds to the end of the class period. If you have not left a comment, please make sure that you do so. That would be phenomenal and fantastic. And then we'll all high five when the time is appropriate. Probably never, but we'll see how that goes. You guys heard they changed the guidelines for if you travel out of state. If you travel out of state and you've been fully vaccinated, you do not have to quarantine for 2 weeks. Yeah, I think you mentioned that last time. Oh, I mentioned it to you guys yesterday. I see him every day. Weird. Anyway, yeah, I'm gonna sign off.
You know, I first thing of the vaccine the other day.